Hey everyone, welcome back to our channel. Today we're diving into an exciting topic that sounds like it's right out of a science fiction movie, faster than light travel. Imagine zipping across the galaxy in the blink of an eye. But here's the thing, it might not be as far-fetched as we once thought. Recently, ENASA has made some exciting progress with warp drive technology, bringing us closer to the possibility of traveling faster than light. Let's explore the science, the challenges, and the latest developments in warp drive technology. So, what exactly is a warp drive? The concept originated from science fiction, especially popularized by shows like Star Trek. A warp drive is a theoretical means of propulsion that would enable a spacecraft to travel faster than light by bending or warping space itself. Essentially, the idea is to compress space in front of the ship and expand it behind, creating a sort of wave that moves faster than light. Instead of moving through space, the ship would be moving space itself. Sounds mind-bending, right? But this isn't just fantasy. There's real science behind it, and physicists have been exploring the mathematics of warp drives for decades now. To understand why warp drives are so groundbreaking, we need to talk about Einstein's theory of relativity. According to relativity, the speed of light around 299,792 kilometers per second is the ultimate speed limit. Nothing with mass can reach, let alone exceed, this speed without requiring infinite energy. That's why traditional rockets or engines won't work for interstellar travel, even at near light speeds. Trips to distant stars would take hundreds or thousands of years. But warp drive technology sidesteps this issue. Instead of moving the ship at light speed, it theoretically changes space itself, meaning that technically, the ship doesn't break Einstein's rules. Intriguing, isn't it? Back in the 1990s, physicist Miguel Alcubierre proposed a mathematical model for a warp drive based on Einstein's equations. According to his theory, if we could manipulate a massive amount of energy, we could theoretically create a warp bubble around a spacecraft. This bubble would allow the craft to travel at superluminal speeds without violating the laws of physics. ENASA's EagleWorks laboratory, led by Dr. Harold Sonny White, has been investigating this concept. Recently, they discovered new ways to reduce the enormous energy requirements, making warp drive more feasible. Though it's still far from becoming a reality, these findings have ignited hope in the scientific community. Despite the promising advances, there are still some huge challenges to overcome. One of the biggest is the amount of energy required. Early calculations suggested it would take more energy than what's in the observable universe to create a warp bubble. However, recent studies have brought that down to the energy equivalent of a massive planet, which is still a lot but technically possible. Another major hurdle is controlling and stabilizing the warp bubble itself, as any instability could be catastrophic. Scientists are also grappling with other complex questions, like potential radiation hazards and how to stop or slow down once the craft reaches its destination. If scientists manage to create a warp drive, the implications for humanity would be immense. Interstellar travel could become a reality, allowing us to visit distant star systems and perhaps even find habitable exoplanets. This technology could lead to the exploration and colonization of other worlds, solving issues like overpopulation and resource depletion here on Earth. Of course, we're still a long way from achieving warp speed, but ENASA's ongoing research is a step in the right direction. With each new discovery, we inch closer to a future where faster than light travel isn't just science fiction, but a part of our everyday reality. One of the most complex aspects of creating a warp drive involves exotic matter and negative energy. Unlike ordinary matter, exotic matter has unusual properties, including negative mass or energy. This type of matter would theoretically be required to create and sustain a warp bubble. Negative energy could counteract gravity, allowing the warp bubble to form and persist. Unfortunately, exotic matter has never been observed in nature, and creating it artificially is currently beyond our technological capabilities. Nevertheless, Researchers are studying how quantum mechanics might offer clues to producing negative energy in controlled conditions. Quantum field theory, which governs the behavior of particles at the smallest scales, also comes into play when discussing warp drives. Some scientists speculate that, under certain conditions, quantum fluctuations might produce the required negative energy. NASA and other researchers are exploring theoretical models, looking for ways that quantum fields might be manipulated to generate the exotic matter or energy needed. Though highly theoretical, quantum field theory offers tantalizing possibilities for advancing warp drive research. When it comes to powering a warp drive, energy is a major issue. Early calculations suggested that the energy required to warp space would be astronomical. While recent discoveries have reduced this requirement, the energy still needed is immense. Current fuel types like chemical, nuclear, or even ion propulsion are insufficient for generating the vast energy warp drives would require. Future warp drives might depend on new energy sources, like fusion or antimatter, both of which are still under development. Achieving a warp drive might ultimately depend on an energy breakthrough that redefines our understanding of power generation. Navigation at faster than light speeds presents unique challenges. In conventional space travel, spacecraft rely on sensors to guide them around stars, planets, and other celestial bodies. But warp drives would push a craft through space at such speeds that it may be challenging to see and respond to objects in the path. Scientists are considering how to create advanced navigation systems that could map out courses before the journey begins. Sensors may need to adapt to the strange effects of warped space, offering real-time feedback to help navigate interstellar distances safely. The Aluer Metric, based on Einstein's equations of general relativity, mathematically describes a warp drive's theoretical framework. This complex model relies on Einstein's understanding of space-time and suggests that a warp bubble could allow a spacecraft to move through space-time without violating relativity. Einstein's equations explain how mass and energy warp space around them, which is the essence of how a warp bubble would function. Physicists continue to study the Aluer Metric, hoping to refine it and get closer to building a warp drive. While NASA and others have made theoretical progress, current warp drive prototypes are limited to small-scale experiments and do not achieve superluminal, faster than light travel. These prototypes allow researchers to test aspects of space manipulation on a very small scale. Scientists continue to refine these early models, but it may be decades before even a basic warp field generator can be tested in real space. Gravitational waves, ripples in space-time caused by massive objects like black holes, could offer insight into warp mechanics. If scientists can understand how gravity waves move through space, they might be able to manipulate similar waves to form and control a warp bubble. By studying gravity waves, researchers hope to gather valuable information that could apply to the development of practical warp drives. If a warp drive becomes a reality, it could have profound effects on the space-time continuum. Moving at faster than light speeds could create paradoxes or even destabilize space-time. Researchers are still studying what these effects might entail. Would they cause unintended consequences, or would the universe self-correct in some way? Warp drive development must consider these potential risks, as altering the fabric of reality may carry unforeseen consequences. Antimatter is often suggested as a potential energy source for warp drives due to its high energy output. Exploring nearby star systems could yield discoveries about new planets, potential life, and valuable resources. Interstellar travel might also provide insights into the nature of the universe itself, answering age-old questions about its formation, composition, and ultimate fate. Artificial intelligence, AI, could be essential for navigating at warp speeds. The high-speed calculations and rapid decision-making required for warp travel could be more than a human pilot can handle. Advanced AI systems could plot safe courses, avoid obstacles, and even make split-second adjustments during warp travel. The collaboration of AI and warp technology might be the key to safe, efficient interstellar journeys. Wormholes are another theoretical concept for faster-than-light travel, often compared to warp drives. Wormholes, hypothetical tunnels in space-time, would allow instant travel between distant points. However, creating stable wormholes is as challenging, if not more so, than developing a warp drive. While both offer ways to traverse the universe quickly, warp drives could be more feasible, as they don't require the same level of space-time manipulation that wormholes do. The idea of warp drives is deeply rooted in science fiction, which influences public perception. From Star Trek to Star Wars, warp drives have captivated audiences. However, popular culture has also shaped misconceptions. Real warp drive research is often more complex and challenging than fiction portrays. Communicating the realistic science behind warp drives helps the public understand both the possibilities and limitations. With warp technology could come ethical questions. Would humanity be responsible in exploring new worlds? What if intelligent life is discovered? Would it affect our right to travel freely in the cosmos? Some scientists believe we should proceed with caution to avoid harmful effects on other worlds or civilizations. Warp drives present moral challenges about our place and role in the universe. Advancing warp drive technology will likely require global collaboration. Countries around the world are developing space programs, and working together could accelerate breakthroughs. International teams could pool resources, share research, and address the challenges more efficiently. Organizations like NASA, ESA, and private companies are already pushing the boundaries of space exploration. The prospect of warp technology might encourage unprecedented global cooperation with the shared goal of interstellar exploration. One often overlooked aspect of faster-than-light travel is communication. Traditional radio signals, even those traveling at light speed, would struggle to keep up with a warp-speed spacecraft. This means scientists would need to develop new forms of communication, potentially utilizing quantum entanglement or advanced AI to transmit information instantly. Achieving faster-than-light travel would transform not only transportation, but also how we communicate across vast cosmic distances. With a warp drive, humanity could visit potentially habitable planets within neighboring star systems. This capability could significantly impact the search for extraterrestrial life, allowing us to investigate distant exoplanets up close. Imagine landing probes or even manned missions on planets that could support life. While this technology is far off, the possibility of warp travel brings new hope to the field of astrobiology and the quest to answer the age-old question, are we alone? Traveling at warp speeds could have unknown effects on the human body. Scientists would need to ensure that human physiology can withstand the conditions of warped space, radiation exposure, stress from high-speed travel, and the effects of being in an altered space-time bubble could impact astronauts' health. Research into protecting the human body during extreme space travel will be essential to ensure safe, sustainable journeys in the future. Private space companies like SpaceX, Blue Origin, and others are already reshaping the space industry. While government agencies have traditionally led space exploration, private companies could play a key role in warp drive development. These companies bring innovation, efficiency, and new funding sources that might accelerate breakthroughs. Partnerships between the private and public sectors could be instrumental in making warp drives a reality sooner than expected. A working warp drive could revolutionize the global economy, opening up new industries and opportunities. For instance, it could enable mining of resources from distant planets or asteroids, leading to an influx of rare materials. Tourism might even expand to interstellar levels, allowing ordinary people to experience space travel. The economic possibilities are vast, though they also come with ethical and environmental considerations that must be managed. One potential solution for powering warp drives could involve harvesting energy in deep space. Solar panels work well close to the sun, but they become ineffective in deep space. Researchers are exploring ways to harness energy from other cosmic sources, like capturing particles from cosmic rays or even exploring dark energy. By harvesting energy on the go, spacecraft might sustain warp travel without carrying enormous fuel supplies. Beyond exploration, warp drive technology could play a role in planetary defense. A warp-capable spacecraft could potentially deflect or destroy hazardous asteroids before they reach Earth. It could also serve as a rapid response system to any threats detected within our solar system. Though it's still in the realm of science fiction, warp technology may one day provide tools to protect our planet from cosmic dangers. As with any powerful technology, warp drives would raise environmental concerns. Traveling through space at unprecedented speeds might have an impact on the regions of space we pass through, altering particles or leaving cosmic footprints. Scientists are considering how warp travel might impact the cosmic environment, as well as ways to ensure this technology is as clean and non-disruptive as possible. The development of warp drives could profoundly impact human culture, opening up new ways of thinking about our place in the universe. As interstellar travel becomes possible, it could foster a new era of unity and curiosity. The idea that Earth is part of a larger cosmic community might inspire new art, literature, and philosophies, helping humanity rethink its role and responsibilities in the universe. The principles behind warp drives could have applications beyond space travel. If we understand how to manipulate gravity in space, we might apply this technology to solve problems here on Earth. Imagine a world with gravity-defying structures or transportation systems that defy traditional physics. The potential for practical applications could revolutionize engineering, architecture, and transportation. A functioning warp drive would push humanity to the frontier of scientific discovery. With it, scientists could conduct experiments and gather data from unexplored regions of space. Warp technology would enable closer study of phenomena like black holes, neutron stars, and dark matter. These insights could potentially rewrite our understanding of physics and offer answers to some of the universe's deepest mysteries. If warp drives enable us to reach other star systems, humanity might encounter extraterrestrial civilizations. This possibility raises ethical questions about interacting with alien life. What if our presence disrupts their way of life? How do we balance exploration with respect for other forms of life? These ethical dilemmas require careful consideration as we explore faster-than-light travel. One of the benefits of a warp bubble is the potential for creating artificial gravity within the spacecraft. This could solve a significant problem in long-term space travel, as microgravity environments can harm astronauts' health. Artificial gravity through warp bubbles could make interstellar journeys more comfortable and sustainable for human passengers. Stopping or slowing down at warp speeds poses an enormous challenge. In conventional travel, deceleration is a straightforward process, but at warp speed, it's more complicated. Researchers need to understand how to safely exit the warp bubble and return to normal space. If they succeed, it will pave the way for controlled, safe, faster-than-light journeys. With warp drive technology, humanity could establish colonies on habitable planets in other star systems, extending our presence in the cosmos. This would involve developing sustainable habitats, adapting to new environments, and possibly modifying human biology to thrive on other worlds. Colonizing distant planets could become an eventual goal, helping humanity expand its footprint beyond Earth. The concept of warp drives brings with it the tantalizing notion of time travel. Some theories suggest that moving at faster-than-light speeds could result in time dilation or even the possibility of moving backward in time. If this holds true, warp technology could have profound implications for our understanding of time itself. However, scientists are cautious, as the effects of time manipulation could lead to paradoxes and unforeseen consequences. Warp drives could redefine humanity's role in the universe, transforming us into true cosmic explorers. With the ability to travel vast distances, humans could become stewards of the cosmos, responsible for exploring, understanding, and preserving the universe. This new role may foster a greater sense of unity, encouraging us to work together in facing both earthly and cosmic challenges. Even if warp drives remain a distant goal, each discovery in physics and engineering brings us closer. Ongoing advancements in fields like quantum physics, energy research, and materials science will continue to feed into warp drive research. With each new breakthrough, humanity takes one more step toward achieving faster than light travel, bringing this dream closer to reality. Supercomputers are essential tools in simulating warp drive conditions. To build a working warp drive, scientists must first model how space-time behaves under extreme conditions. Supercomputers are used to simulate the effects of different warp drive models, exploring how they would interact with space-time, energy, and matter. These simulations allow researchers to test theoretical warp drive models without the need for physical experimentation, accelerating progress and providing insights into what might work in real-world applications. One of the biggest obstacles to creating a practical warp drive is ensuring the stability of the warp bubble. While the theoretical concept of a warp bubble looks promising, ensuring that this bubble can remain stable over long distances is a different challenge. Scientists are exploring various techniques to keep the bubble from collapsing, such as controlling the exotic matter and energy fluctuations that would be involved. Research into quantum mechanics, coupled with new computational models, may hold the key to stabilizing warp bubbles and making them practical for space travel. One exciting prospect of warp drive technology is the potential to harvest resources from distant planets, asteroids, and other celestial bodies. With the ability to travel across the galaxy, humanity could access vast amounts of resources, such as rare minerals, water, and even energy sources like helium-3. This could revolutionize industries back on Earth, reduce reliance on terrestrial resources, and open up new possibilities for space-based manufacturing and energy production. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.